Good morning, pilot teachers and students. Good morning, class.
Good morning, sir.
Right, thank you. You may sit down. Okay, very good. In our last lesson, we went through looking at force and basically explaining force. Force is sometimes a push or a pull. Okay, or a better definition of a force can be seen as something which can cause the object to move, or when it causes that object to move, it can either slow it down or stop it from that movement, or sometimes this force can change the shape of object. And we have seen some effects of force in our last lesson. A force can simply make object to either speed up or slow down. It can change the direction of the motion, or it can simply cause object to change shape by compressing, stretching, or it can be bending and twisting. Those are some effects of forces. Now, in this lesson, we'll be basically going through force also. The topic is still force, but the subtopic will be contact and also the field forces. Now, looking at this, from that definition, a field force is simply a force that acts at a distance, which means they do not come in contact with an object. Okay, that is for field force. And also forces can be classified into contact force. Contact forces are forces that act when in contact with an object. So what I'd like you to do now is to quickly go through, copy the definition of that, and then I will go through each one of those examples given and then explain to you one by one. Everybody finished? Okay, now on to the next part of the information on force. Okay, basically, you'll find that the instrument used to measure a force is a spring balance or a force meter. Okay, I don't have a spring balance now. Probably I might show you the spring balance in our next lesson. Okay, and you'll find that the unit of force is in Newton, or if it is in dimensional unit, you have m times length times square. Now that is the mass times acceleration. Length is square is for acceleration. Or it can be in SI units as kilogram meters per second square. All right, quickly have this one. You can do a group discussion by looking at those ones. Okay, discuss it in groups. Go through and then you discuss those some example whether it is a contact or field force. Okay, you have to go into groups and then you discuss whether those examples given on the board are contact or field forces. Okay? Four of you on this. And so you discuss those examples, contact or field forces. Three of you, okay. You can discuss this as a contact or field force. Okay, 1, 2, 3, and 4. You discuss those examples as whether they are contact or field force, and you 4 together, okay? All right, after having that information, the instrument used in measuring force and also the unit for force. Okay, pilot students, you can now go into groups. And here are some examples of forces given. Right? By looking at these forces, you can now discuss it among, okay, let's say in groups, and then you classify these forces or put them under whether these forces are contact or field forces. Okay, model class, you can do the same now. I'll give you some time and then you can come and explain. Okay, I will go through my explanation of this one and then you can classify them later on. Right, the first one is weight or the force of gravity. Right, for example, if we have to look at this one, this is a table tennis ball. So what I'll do is just look at this one. Right, some dropping this one. Okay. Right, the force of gravity is causing this object to fall towards the center of the earth. Okay, what can you tell about this one? Is it a contact or field force? Okay, you will discuss it later on. Okay, that is for number one. Right, number two, you have the resistance such as friction on water, or it can be air resistance. Right, air resistance can simply refer to anything. For example, if I'm having these two and this one. Okay, just look at the time that I will drop these two. Okay, which one of those is falling first? Okay, the bone is falling first. Why? Okay, you will discuss that later on as well. All right, looking at the second one, you find the tension forces as in ropes or surface tension on water. Right, I have liquid here, but if you can provide, let's say, if you make a bubble form and if you put it on top of water, then it will float. That is what is known as surface tension. But if you have a rope and then try to pull it apart, probably you'll try all your best to pull it, or sometimes break the rope. Right? Surface tension is simply the particles that make up the rope. There is a cohesion between those particles that you are trying to stretch. Okay, and okay, you have the other force like a bulldozer that is pushing gravel. That is a contact force. Right? Magnetic forces between a compass and Earth's needle or field should be FEILT. Right? You have okay, if I only have a magnet, this is parts of a magnet that have been broken. So I have some iron filings here. Right, this is just a piece of metal, but you will find as I bring it closer, okay, it is taken towards the magnet. Also looking at what I will do with the iron filings, right, can somebody come up and help me hold this? Okay, Michael, you hold this one. There. Okay, we will be moving the magnet around, okay? Okay, you find that there is no iron filings on this magnet, but you saw the movement of these iron filings, right? You explain whether it is a contact or field force, and turning forces or moments on spanner and also screwdriver, right? The upthrust force on floating objects. For example, when you immerse something in water or liquid and that liquid is partially immersed in liquid, you have this object which has lost weight apparently, meaning that the liquid or the water is now supporting that object. So that force provided by the liquid is known as the upthrust. All right, given some, right, we have to take this one fast so that, okay, look at this. If I have to leave this one, what do you see? Okay, it is floating on the surface of the water. Now why this happens is because of the upthrust, okay, provided by that liquid. Now Archimedes was able to come up and then find that if you have to immerse something that is more denser than a liquid, and if it displaces the liquid, the weight of that liquid will be equal to the upthrust force that is provided by that liquid. So in this case, the liquid provided the upthrust. Okay, you say whether it is a contact or field force. And finally, electrical forces between charged particles. For example, if you have to rub your ruler or something like a pen, or your hands together and then put it closer to your hair on the skin, you will find that this hair will be attracted towards the ruler or pencil. Now this happens because of those electrically charged particles. So simply classify this one, classify them, and then put them into contact or field force. I will ask you to come up and then you explain, okay? Right, quickly go in, discuss it among yourself. So I want to discuss, and then you can go up. Yeah, you copy that one. Any rope, kind of some that string. and we'll just well, overspring, expansion forces overspring by which it changes in. Yeah. Yeah. Expansion, contraction. Expansion, or it can be contraction force. When you are expanding, you are applying force. Okay. All right, we will now go through the demonstration of it. Some of those examples require a group demonstration. Probably somebody in the group can come up and then help you demonstrate those, the example of forces, and then classify whether these forces are contact or field force. But some may require individual student to explain. All right, we'll start off with the first one, the weight force of gravity. Probably will ask Allen's group. Okay, Allen's group. You can come up and then explain the weight force. Okay, if it means to demonstrate, you have some materials here in which you can demonstrate. Okay, quickly let's have group number. Okay, Alan's group for the first one. All of you. This group, you get ready for the second one, resistance, or it can be using that piece of metal there to saw on the inclined plane. Okay. Can you see that piece of timber there? Okay, you put it on that inclined plane, adjust it, and then you roll it. Yeah, let it roll. Yeah, and then you adjust those until it cannot move anymore. Okay, you put that up, you push it, and then let it move, and then you adjust the height of that inclined plane, and then you push it at the certain, and then you compare the frictional force that is provided by the surface. Okay. All right, you can start with number one. You still want to number two. Okay, you start. Okay, number two. Okay, Mark. Which one are you doing? Okay, you started with number one. We just go by that. Number one.
Number one, weight or force of gravity is, it's not a contact force but a field force, because gravity is when something comes into gravity does not need anything to come into contact with, but it's only the field of the earth, the magnetic field inside the earth's crust that pulls things down. So Josh will show us how it works. Josh, can you take the ball out?
So as you can see, gravity is an invisible force that acts upon a body like this ball, which when I drop it, it will go down to its force of gravity. Thank you.
Right, good. The first one is simply the field force, because you cannot see the force that is applied but you can see the effect of the force as this ball was being forced towards the center of the earth. Good. Number one is field force. Right? That can be field force. Right, let's have question for number two. Right, this group to come up quickly using, right. You can use paper or you can use that one as well. Okay, you adjust this one, and then you do it this way, or you can use that one, paper and the ball to show air resistance. Okay, this one is resistance on the surface, but you can do air resistance as well, okay? Yeah.
as the object is going down, it shows the resistance the air forcing it back up. So it shows the resistance of air forcing the weight back up, so it's a contact force.
Okay, try that. Okay. As stated, the paper in that ball paper and the ball that was falling down is an example of air resistance. But if you want to find the resistance on friction is something that can resist motion. Now in this one, it is in contact with this surface. That is why, right, when you let it go. But if you have to adjust this one, okay, it cannot move at all. So that is simply contact force. Right, let's have the next person. Michael, can you demonstrate and tell us whether that is contact or field force? Okay, yeah, you can use this one.
Tension force is a contact force because if I was to pull the ropes apart, there is no field force acting on it because the forces that are applied to the rope while they are being pulled apart act on the object, not at a distance from the object, as I will show you now.
Okay, very good. So tension force on the rope is simply a contact force. Okay, we will have Sulaiman to all right, you can explain. Just explain.
Okay, to identify whether we are working with a field force or a contact force, must first identify the object plus what sort of force is acting upon it. Okay, in this instance, we have a bulldozer and the gravel, and the bulldozer is applying the force here, and the gravel is sort of like acting as the force of, we could say, like resistance. So the bulldozer is physically acting on the gravel here. So our best answer would be a contact force.
Okay, very good. Okay, now on to the next one, and that is the magnetic force between a compass and Earth's field. Anyway, we got a magnet here and also the iron filings, so you can come up and show that one. Okay, we'll have this group. Okay, Ume, your group can demonstrate that quickly. Right, firstly, when you get up there, state whether it is contact, and then you do your explanation, go back.
The magnetic forces between a compass and the Earth's field is classified under field forces.
As you can see, the magnet doesn't act on the object. It acts at the distance and affects the magnetic waves. It's a field force.
Okay. If you do it this way, it looks more like a contact force. But anyway, if you want to see the movement, but simply what she did at first was to have these iron filings, and then when she brought this one, came close, right? Sometimes people may see this one as a contact force that is applied, but if you want to do that and show clearly whether it is not a contact force, you can have it on a piece of paper, and then simply moving that right underneath. Okay, simply it is not coming in contact with those iron filings. So we can simply say that one is a right field force. Good. Okay. To the next one. Right, somebody, can you tell us whether that is a contact or field force? Can you pass it to Maima? You tell us whether that expansion force on a spring by which is a field force or contact.
The expansion force is classified under contact force because you apply force to answer. Because there's a force in there which you can pull and then it can go back to its original shape.
Okay, very good. This one will be a contact force, and this one will be field force contact. Right, finally, we have the other two, which is a turning force or moment within a screwdriver or spanner will be, that will be contact force. And upthrust force on a floating object will be contact or field force. Right, you have to consider this one again, whether it is a contact or field force, but which one of those come first? Huh? Is it a field force or contact force? Okay, pass this mic to Enara. You tell us whether it is a contact or field force.
It is a field force because the forces acting on it cannot be seen. The same force that is applied from the top is the same as the force applied from the bottom.
So it is a field
Force.
field force. Very good. That is correct. If you look at the upthrust, it is simply a, where is our object? Okay, here. If I have to leave this one, right, it is now floating on this water. But why is it not falling downwards? Okay, because the water is forcing it upwards. But then if you have to look at this, the first thing is that the force of gravity must always push any object towards the center of the earth. Just imagine if there was no liquid in here, you will find that this object will be resting on this surface. But because of this liquid, we are having this one as an upthrust that is forming. So that is why we can classify this upthrust as a field force. And after the field force, we can simply say it is now in contact with water and it is a contact force. Right, so we can simply say field and contact force. And the last one should be, okay, Marvin, you tell us whether it is a field force. Okay, pass that mic to him.
It is a field force because it involves positive and negative charges.
Very good. It is a field force. When these objects are charged, they will have to attract other charged objects. For example, if they are positive, you will find that positive and positive will have to repel. If it is negative and positive, it will have to attract. All right, very good. You've just seen the effects of these forces and also what type of force they will come under, whether it is a field force or contact force. A field force is a force that will act at a distance, while a contact force is a force that will act when in contact with that object. Okay, our keyword for today is on contact and field force. Okay, once again, good morning. Good afternoon, pilot teachers and students.